Secondary endosymbiosis is showing the origins of chloroplasts in the non-archaeplastid lineages, because the archaeplastid lineages are from the primary endosymbiosis event. But these non-archaeplastid lineages, as we'll see, like diatoms, are from secondary events. So secondary, you can think of that as the alga is being engulfed. Primary was a bacterium. Secondary is a eukaryote, in this case, in both of these cases, an alga, an individual algae cell. And just to note that this happened many times in the history of life, so we get a lot of different lineages that come from different secondary endosymbiosis events. We start with a secondary eukaryotic host cell. And I've highlighted the membrane here in this yellow color. It is a eukaryotic cell. It has a nucleus. And it also has the mitochondria in it. There are many mitochondria. I've just drawn one here. And just to note that none of this is to scale as far as what's going to be bigger or smaller. It's just representing the structures that are present. Then we have a red or green alga cell. So this is a single cell here. It also is a eukaryotic cell, so it has a nucleus. It also has mitochondria, and it has chloroplasts, right? Because this is one that came from that engulfing of the cyanobacterium. So this algal cell here is engulfed by the secondary eukaryotic host cell. Engulfing an algal cell is not abnormal for a eukaryotic cell to do. That would be how it gets food. It's eating it essentially. But in this case, an unusual thing did happen is that it didn't get digested. And so that gives the host cell an advantage because now it can do photosynthesis because it has essentially the chloroplast inside of it. And that means it can make its own food so it doesn't have to go out and eat anymore and find, other organisms to engulf them. At this point, though, it could be considered an endosymbiont organism. The algae would be like an endosymbiont living inside a host cell until it becomes dependent on living inside. And it does that because some genes from the algal endosymbiont are transferred to the host cell nucleus. And then, those genes code for proteins that are necessary for that endosymbiont to exist. And that means now it's dependent on being where the nucleus is of the host cell. So basically this guy inside needs genes that are now in the host nucleus. So it becomes dependent, and now we consider it like a true chloroplast organelle, not its own entity living inside of a cell.